So far in this module, we have talked about measures of center with mean and median. We've talked about measures of spread with variance and standard deviation. And in this video, let's talk about measures of position with Z-score and percentile. Now, we've actually already talked about Z-score a little bit without you knowing it, because it connects nicely with the discussion involving the empirical rule. So let's think back to this example involving the bell curve distribution of heights of adult men in the US. And remember that the heights of adult men in the US had a mean of 69 and a standard deviation of 3. And when we talked about this empirical rule, we labeled this plot as follows, and we were able to conclude things such as 68% of adult men in the US are between 5'6" and 6 foot tall, or 95% of adult men in the US are between 63 inches and 75 inches tall. But instead of focusing on a range like the empirical rule gives us, suppose we wanted to focus on the position of one specific data point. So let's take an individual that is maybe 72 inches tall, and let's think how we could describe how that person relates to everybody else in the distribution. And the way that we do it is we say, well, how many standard deviations is that person from the mean? And as we could see in this plot here, this particular individual at 72 inches tall is exactly 1 standard deviation above the mean. So we would say that this person's Z-score is equal to 1. Or this individual right here at 75 inches tall, you could see is exactly 2 standard deviations above the mean. So we would say that their Z-score would be equal to 2. Or go to the far left of the distribution, this person that is 60 inches tall is 3 standard deviations below the mean, so we would say that their Z-score is -3. And the person that is 5 feet 9 inches tall, that is right at the mean, has a Z-score of 0, because they are 0 standard deviations away from the mean. And so Z-score is simply the number of standard deviations that a particular person or a particular data point is from the mean. And the formula for Z-score is this right here. Z is equal to x minus mu divided by sigma. If you think about it, you can see that this formula completely captures what the definition is. You're looking at the distance between a data point and the mean, and then seeing how many standard deviations goes into that distance. So if you just take this data point of 72, and if you plug that in for x, subtracted the mean of 69, and then said how many standard deviations go into that distance, you would see that the answer would be 1. And so that's why 72 has a Z-score of 1. So Z-score is going to be a very important tool for us in this class, but not necessarily at this point. Our focus at this point in terms of measures of position is more so going to be on percentiles. And again, this is also used to denote the position of a data point in a particular distribution. Now, you've all probably experienced percentiles at some point because most of us have taken a standardized test, and they often tell you your percentile, your score, how you do on that standardized test. They'll say you performed at the 10th percentile. And if you performed at the 10th percentile in a subject area, then that is saying that you did better than 10% of the people. So it's separating you from the lowest 10% of the people. But there's 90% of the people that performed higher than you. So the 10th percentile separates the lowest 10% from the higher 90%. Or maybe they said you're in the 60th percentile. The 60th percentile separates the lower 60% from the higher 40%. So somebody that performs in the 60th percentile is performing higher than 60% of the population, and 40% of the population is performing higher than them. Somebody that's performing in the 99th percentile is performing higher or better than 99% of the entire population. The percentiles that we are going to be most interested in at this point are the 25th percentile, the 50th percentile, and the 75th percentile. These percentiles are known as the quartiles. I'm going to write that down here. And in particular, the 25th percentile is Q1, quartile 1. The 75th percentile is Q3, quartile 3. we don't usually describe the 50th percentile as Q2. Instead, we call it by its other name, the median. So let's take a data set, plug it into the calculator, and see if we can use that one variable stats tool that we've been using the entire module to come up with these important percentiles. And then we'll take it a little bit further after that. So if you're following along in the notes, you'll notice that the data that I've got here corresponds with the number of seconds of a typical phone call for a class of 25 people. So if you look through the list, you could see that one person says that their typical phone call is 360 seconds. Another person says 60 seconds. Another person says 20 seconds. And you can scroll down and you'll see in the data, there's even somebody that says 0 seconds. There's somebody with 900 seconds. And so we've got quite the range. So let's see if we can get these percentiles. And so just like we've done earlier in the class, you press Stat Edit, you enter your data into the list, and then we press Stat, go over to Calc, one variable stats, that's number 1. And I need to change this to make sure it reflects list 1 because that's the list that I've entered my data in. And I can go down and just hit calculate. I don't want anything in frequency list at this point. So I press calculate and you see you've got sample mean, all these other things. But what we're interested in at the moment is near the bottom. And you could see we have Q1 is equal to 60. So our 25th percentile is 60. We have a median of 120, and we have Q3, our third quartile, our 75th percentile is 300. So the way that we interpret this is, since this is the 25th percentile, 25% of the class talks less than 60 seconds per phone call, whereas 75% of the class would be talking more than that. Or with this one, 50% of the class is talking less than 120 seconds per phone call, and 50% is talking more than 120 seconds per phone call. And with Q3, since this is the 75th percentile, you would say the person that's talking for 300 seconds is talking longer than 75% of the class, but there's still 25% of the class that might be talking longer than that person. Okay, so the other thing that you're going to see from the calculator at this point is it's not just giving you those quartiles, it's actually giving us something a little bit more. So it's giving us the minimum value in this one var stats menu. It's giving us Q1, the median, Q3, and then the max. That is described as the 5-number summary. And sometimes it's just a really nice way to capture what's happening across an entire data set. On top of that, we're often interested in locating or identifying certain data points in a data set that are outliers with respect to the other data. And the process to identify an outlier begins by finding what we call the interquartile range. Now, the interquartile range is just the third quartile minus the first quartile. So it is quite literally Q3 minus Q1. And in this case, if we do Q3 minus Q1, you see that we get an interquartile range of 240. That is going to be important in working with these formulas that help us create boundaries to identify our outliers. And so what we're going to do is we're going to use these formulas, find these boundaries, and then if we have data points lower than this lower boundary or higher than the upper boundary, then we'll characterize those data points as outliers. So let's use these formulas right now and find the outlier boundaries for our data in this example. And after we do all of that, we're going to visualize this. And I'll show you how we can visualize this in what's called a box plot in the calculator. So let's get our lower boundary by finding, you can see it's the first quartile minus 1.5 times that interquartile range. And so for us, our first quartile is 60, so we would say 60 minus 1.5 times 240. And let's plug this into the calculator. So 60 minus 1.5, whoops, I want to say times 240, and that gives me negative 300. The upper boundary would be Q3 plus 1.5 times the IQR, and Q3 was 300. Here, make sure you're saying plus 1.5 times 240, and this number, let's see, 300 plus 1.5 times 240, and that gives us 660. And so our outliers are going to be any of the values that are lower than negative 300, which obviously you couldn't have anything lower than 0. So we don't have any outliers on the low end. But if we have any data points that are greater than 660, then they will be our outliers. And so let's go back into our list and see if we can identify exactly what the outliers are. And then I'll show you visually how we're going to be able to see that. So at first, these first 10 data points or so, it does not look like we have any outliers in there. Looking for numbers that are greater than 660. Okay, let's keep going down. Now there's a data point at 900, so we know that 900 is definitely an outlier. And continuing down here, it looks like 900 is the only outlier. So we have one outlier in all of this data, at least according to these definitions right here. Okay, so now let's take all of this information and visualize it. Let's plot it, and we can do that plot in the graphing calculator. So what we're going to do is we're going to create this box plot, and here are the steps to do so. We are going to press Stat Edit, get the data entered into L1. That's already been done. Then we press second y equals to turn the stat plot on, and we've done this before. So we say second y equals, we turn the plot on, except this time we have to select the box plot. Now there are two different box plots that we have in the graphing calculator. There's this box plot that you're seeing right here that has a couple of dots after it, and then there's this box plot that you have right here that does not. The second box plot that you see basically ignores any points from being outliers, and so we don't want that. We want to acknowledge an outlier if it exists. So I want you to select the box plot that has the dots after it. Our X list is L1, so now we press zoom number 9. So I say zoom number 9, and here is my box plot. And the nice thing with this box plot is if you press the trace button, you'll be able to clearly see the 5-number summary. So you'll get some of those main percentiles, those quartiles that we've been talking about. So let's press trace, and you can see you get the minimum value. This first line in the box plot, that is Q1. That's always the case. That first line in a box plot that begins the box part of it is Q1. That second line, you can see as we go over, is going to be the median. And then this third one is Q3, our 75th percentile. As we arrow over, 500. This is not the largest. This is not our maximum value, but this is the largest value prior to any outliers. And then if you arrow over again, you'll even land on the outlier. And we see that the maximum value and that outlier over there is 900. And the way that you interpret this box plot is that first line that you see represents the first 25% of your data. And then we have 25% of our data between Q1 and the median, another 25% of the data between this median line and this Q3 line, and again, another 25% of your data in that last line segment. So it's another way to give you an idea of how your data are distributed. Okay, so that is it for Module 3. But there's still a couple videos remaining, and I want to encourage you to check those out. One of them is a very powerful example of a lot of the terms that we've been seeing recently, and the other one goes over a number of practice problems covering material from the entire module. So check those out. Thanks.